Okay, let's work on homework for week 2. So let's see what we have. Question number 1. If you are using exponential smoothing for forecasting an annual time series of revenue, what is your forecast for the next year if the smoothed value for the year is 32.4? First of all, what is exponential smoothing for forecasting an annual time series revenue? So there always can be a little bit plus minus difference in revenue, right? Some errors here and there. In one year a little bit more, and one year a little bit less. But if you provide through all this data graph, connect these years, you're gonna get exponential graph. And there is a way to do exponential smoothing, so to kind of adjust this error and get the smooth graph. So that's to make it easier for forecasting. So in this case, if it's asking for next year for smoothen value from within 1 year, it's not gonna be much change. Therefore, it's gonna be same 32. Let me type it, 32.4. Okay. Now moving to next one, consider an 11-year moving average used to smooth the time series that was first recorded in 1958. Moving average, we know what it is, average. It's just like adding every year and then dividing by 2. So you can use either mean or you can use median. In this case, we are going to use median, so ignore outliers, okay? So outliers will not affect our average. So if we have 11 years, right, let me draw it, 11 years, 1, 2, 3 in order, remember 5, 6, 7, 8, 9, 10, 11. So to get the median, it's gonna be the 5 here, and it's gonna be the 6th element. It's gonna be your median, right? Or we know from the basic statistics, Q2. Okay, so it's gonna be 6. So since it's gonna be 6, so let's count from 1958. 1958 plus 6, it's gonna be 1964, but if you count 58 also, it's gonna come 1963, okay? Because plus 6, it's gonna be different, 58 and 6, so which means you don't count exactly 58. But if you start counting 58, 59, 60, 61, 62, 63. Okay, so it's going to be 1963. Good job. So, and how many years it's going to be? But this is how we're going to calculate. So, with total amount of element is 11, meaning 11 years. So we have to do for first beginning and for the end of the time period, L minus 1 by 2, okay? And then at the end also we're gonna do L minus 1 by 2. So L is 11, 11 minus 1 is 10, by 2 is 5. At the end of the term, it's still gonna be 5. So, and once we put together, it's gonna be 10. Okay. All right. Now you're using exponential smoothing. Why we are using exponential a lot? Because the It's in practice in economy. It's very common to use exponential smoothing because economies can grow based on exponential smoothing, annual time series concerning revenues. Okay, so let's see. You are using exponential smoothing on an annual time series concerning total revenue in $1,000,000. You decide to use smoothing coefficient W equals 0.2. Every smoothing has the weight or smoothing coefficient, which is going to be between 0 and 1. Okay? Smoothing coefficient can be between 0 and 1, but not 0 or 1. Okay? Next. So, and the other, so okay, and exponential smoothing. So exponential smoothed series being computed in a time period of E 2010. Here we have. Okay. It's a value of the exponentially smoothened series. Okay. For 2010, we have formula. We have calculation in the format 0. Let me do this way so I don't have to go constantly. All right. So we're gonna draw. Yeah, it's not. No, it's not gonna work. Let me see. Okay, let me split it. Much better. Okay. There we go. So we have W, that's W is going to be our weight or a smoothing coefficient that is going to be between 0 and 1, we said. So our value of exponentially smoothed series E for 2010, here we have it, is equal 0.2 times 12.9 and then plus 0.8 times 9.1. Okay, so 0.2 times 12.9 is 0.58. All right, plus 9.1 is 9, 1981, and 2 decimals, 8.19. So if I do plus 8.19, I'm going to get 8.77. So let me type here 8.77. It looks like we did something wrong. All right, let's calculate one more time. 0.2 times 12.9. 0.2 times 12.9. 2.58. Well, why I got 0? Okay. 2.58. And then we do plus 8.19. 10.77. Okay. Let's correct it. 9.77. Let's check. Still says wrong. What's wrong with it? Let me do the other part. 0. It says 0.8. I'm doing a lot of mistakes today. Plus 0.8 times 9.1. 7.28. Okay. So let me add 2.58 and 9.886. Okay, finally. Silly mistakes. So that was the exponentially smoothed value for 2010. Now we want to find for 2011. Question B, it says, what's the smooth value of the series in 2011 if the value of the series in that year is 11.6 million? So for the year 2011, it says 11.6 million. So we are going to use the formula which I previously used based on these numbers you have calculated. So it's going to be smoothing value for 2011. It's going to be equal W smoothing coefficient, or weight, times, it's going to be previous year always, 2011, not previous, but that year, I'm sorry, 2011, because here we used 2010 and they give us the revenue for 2010. So weight times year 2011, and then plus whatever left over from the weight, 1 minus W times E 2010. Okay, so it's going to be the value of the exponential smoothing series for previous year. Okay, let's see. So E 2011 is going to be equal how much is going to be our W? I'm looking at this 2010, which is here, W, it's 0.2. Okay, so 0.2. Why I took this? Because formula here is E20. Let me see. It's going to be E1 E4, okay, let me put this way, 20 and 10, it's going to be equal W times for the first year times 2010, and then plus W, 1 minus W times the previous year, E, whatever N is given, minus 1. So 1 previous year. Here we have finding smoothing value of time the series. It's going to be W times revenue for this year, Y, and then we need to take the leftover, which is going to be complement of the weight, and times previous revenue. Okay, revenue of previous year. So it's going to be 0.2 W in this case. times. For year 2011, we are set 11.6. Let me put this times this type of multiplication so we won't confuse with decimal point. And then plus, it's going to be 0.8, obviously, 1 minus W, 0.8. And for 2010, we got 9.86. Okay, let me do the math. How much it's going to be? 0.2 times 11.6. It's going to be 2.32. And then plus 9.86 times, 9.86 times 0.8. Something is wrong. 1 second. I guess I didn't clean memory well. 0.8 times 9.80. Doesn't type point. 9.86 times 0.8. Got 7.888. Okay, now we are adding this 2.32 and we are getting 10.208. How many decimal, integer or a decimal? So 10.2. Okay. .2. Incorrect. Let me calculate again. Today is not my day. Basic math. So one more time. 11.6 times 0.2, 2.32. Okay. Next, we get 0.8 times 9.86. Okay. 0.8 times 9.86. 7.888 plus 2.32. 10.2. I don't understand what is wrong. I want to see the answer. Let me check again. Let me see what they say. Oh, so 3 digits, but they said here type an integer or a decimal, so they fooled. A decimal I would put, that's why I put 10.2, but it's correct. Okay. So what do we have? Next question. Okay. The following data represent yearly the movie attendance in billions from 2001 to 2008. So complete part A through 9. Okay. So plot the time series. So we need to choose which one is going to be. For that, we are going to use technology.crunch. I'm clicking here saying open StatCrunch. All right, it opened, start crunching here, and then click graph. Oops. Let me go one more time. Start crunch. Click graph. Yeah, okay, chart and column. Yours can be a little bit different, format, but not the data. So what do we have? We are choosing attendance because a subject of our interest is attendance. All right. And what type of graph? I don't want bar, I want plot as we have their lines, so it's gonna be let me see, no, not bar, connected lines, that's what I want. Connected lines, and then click build. What is this? Oh, okay, compute. Okay, here is my graph. The time series, this is a plot. Let me look which one looks like. It's either A or C. Okay, going in the form of 4. I think it's this one. It's going to be. Let me check. Yeah, good job. Now we're going to do next one. We need to fit the 3-year moving average to the data and plot the result. Okay, we need to find 3-year moving average. So I believe I have already prepared Excel spreadsheet. So what you're gonna do, click here and click Excel, open in Excel. It's gonna open it, although I have it already. All right, so I moved already. So for 3 years, I'm going to take this one. I can't work it. Okay, to edit and save, sign in with a subscription. Yeah, I don't have it. Let me see. It has blocked me. So the bottom line is, I'll show you in the class. If you don't know how to work, you just I'll show you. Hold on. I'll show you what you're gonna do. This is your year, and this is attendance. Let's say you have 1.51, you have 1.48, and you have 1.42, and so on. So you are taking first 3 because it's 3 years, and you're gonna put it at 1.51 plus 1.48 plus 1.42 and divide by 3, and that will be your answer. So since let me see if I can do it this one. No, I can't. I'm going to open the solution. For my case, where is it? B, here it is. So as you can see, so well, 157, it stays 157. Then 156, you are going to add 157 plus 156 plus 153 and divide by 3, and you will get 1.5674. And then next 3, 156, 153, 139, add them and put in front of 1.53, which will be 1.5577. I'll show you in the class, okay? Or maybe, yeah, I'll show you in the class. So every 3 years, because it's asking 3 years moving average. All right. This is for B, I believe. Yeah, here it is. Not C. Here it is B. All right, and then again, 1, 2, 3 by 3 you are going. Okay, and that's how you will get the result. The 2001 attendance plus 2002 attendance plus 2003 attendance, and then divide, you get summarize and divide by 3, and you get 1.5533. And then again, 2002 attendance, 2003 attendance, 2004 attendance, add them up, divide by 3, and you get 1.4933, and so on. Okay, and then you plot 3 years moving average. So you are gonna load this to StatCrunch. Let me see. Yeah, it's not gonna bring this. Yeah, and it wants us to build the, where is it? Yeah, here it wants to plot the moving average, is MA of 3, this one. So we need to type it in and then get the result for year 2001 to 2002. So instead of attendance, you place this MA3 in the StatCrunch. Okay. And graph the plot. And you should get something like this, B, the answer. Let me see if I can do it. I need to take a picture of it. Let me see. Let me open. So, and I'm going to use, I'm not going to clean attendance, but I'm going to ignore. So it's gonna be here. Doesn't let me type. Anyway, so you're gonna here type the average, and then again click graph, and then chart, and column. And in this case, you're gonna choose as a column, you're gonna choose average. Here it will show up. Instead of year attendance, you will choose moving average. All right, and horizontal, instead of bar, you will choose horizontal, where is it? Points with connected bars. No, lines, yeah. And it will build the graph for you. All right? If not, I will help you. Okay, for question number 3, for C, what is the fitted value for the 3rd year? We are going to use this formula. Y bar is equal 4.6 plus 1.4 xi. Xi, it's gonna be 3rd year, it's gonna be full 2 years, right? So you're gonna plug 2 and do the math here. 4.6 plus 1.4 times 2 and get the result. And D, what is the fitted trend value for the most recent year? Okay, it's asking here in the word problem the linear trend forecasting equation for an annual time series containing 44 values. So the recent last one 44, so the previous will be 43. So in this formula we plug again 43, 4.6 plus 1.4 times 43, and that's the result you will get, 64.8. And the last one, what's the projected trend forecast 3 years after? So we had 43, right? Counting these years from 1961 to 24, and if you count 61, it's gonna be 43, and then plus 3 years, so 43 plus 3 is gonna be 46. So you plug in this equation again, and you will get the answer. All right, so moving to question number 8. Oh, it's the same thing, you can do it. All right, number 9. Well, let's understand here. Linear trend, quadratic trend. Okay, we'll solve this one.